Hi everyone, welcome you all to the 90 Days to Cat series. I hope you're all doing great, putting a lot of efforts. I hope you've seen the previous video. In this video, we are talking about data interpretation, particularly from a foundation standpoint. A lot of people struggle with speed in DI, take a lot of time solving even simpler problems. There are a few key aspects, also called the hygiene aspects in data interpretation. Work on them for the next 30 days for 5 to 10 minutes every day and feel the difference. Let's talk about the key hygiene aspects. So what are the key hygiene aspects? Not something that you've not heard of. So we'll talk about averages, percentages, fractions, squares, cubes, an art of approximation, getting down to the roots, and finally to power. Let's begin. Beginning with averages, all of you know already what are averages. In very simple terms, averages will be sum upon n. Let's take a very simple example. As far as arithmetic is concerned, you have simpler numbers, you can just add them and divide it by the total number of numbers and get the average. But in case of data interpretation, you don't get simple numbers. You always get some sort of decimals or a lot of zeros. So you have to calculate averages in those scenarios. For that, there is something called an assumed mean method. For example, in this question, if I have to calculate the average, I'll have to do the addition for each of the numbers, right? So let's try adding the numbers. 41 plus 37, 78, plus 30 is 108, plus 52 is 160, plus 45 is 205. Then I have to add the decimals also. 0.8 plus 0.3 plus 0.3. So this becomes 1.4, 2.2, 2.5. So 205 plus 2.5 is 207.5. That's the sum overall. Now I divide this number by 5, right? So what do I get? 4 times, 1 times and 5. So 41.5. So that's the average here. Now even if you calculate this fast, the way I have done it, you will be able to calculate this. You had first calculated these numbers. You had got 205. Then you calculated the decimals, you got 2.5. And in adding these numbers, what if you forget this number? You have to do it because it's a panic scenario in CAT. You forget this number, you take 206 or you take 204, your answer goes for a toss, right? So what is a simpler as well as faster way of doing this? That is assumed mean method. For example, in this case, let's see. Every number has either 0.8 or 0.3. That's the first observation. So the first step towards assumed mean method is assume a mean, right? So in this case, let's take a mean. Some numbers are in 30s, some numbers are in 50 also. So let's take 40, but with that, let's take a 3 also. And you'll realize why did I do it. So assume a mean. You can assume any mean. Okay, you can take any number you want. You can take 30, you can take 40, you can take one of these numbers also. In second, take difference with all the numbers. Now let's take the difference with all the numbers. Your assumed mean is 40.3. Take a difference from here becomes 1.5. Difference from here becomes minus 3. 30.3 difference is minus 10. 52.8 difference is 12.5. 45.3 difference is exactly 5. So 12.5, here you will get 2.5, right? 2.5, and here you have minus 0.5, 2.5 and minus 3. Combine it with 1.5 becomes 1. 5 plus 1 is 6. Now, second step, take a difference. Third step, add all differences. So you added all the difference, we got 6. Fourth, take average of the differences. So what is the average of 6? The average of 6 is 1.2 because there are 5 numbers. Finally, last step, add it to the assumed mean. So you add 1.2 to the assumed mean, which is 40.3, getting 41.5. Now to summarize, first step, assume a mean. What did we do? Assumed 40.3. Second step, take difference. 40.3, taken difference with all the numbers. Finally, third step, add all the differences. We added, we got 6. Finally, took the average of the difference. 6 divided by 5. There are 1, 2, 3, 4, 5. So the average is 1.2. Final step, add this average to the assumed mean. 40.3 plus 1.2, finally 41.5. So for the complex numbers, slightly difficult numbers, this is a better approach, faster approach. lesser chances of committing a mistake. Talking about percentages, you define percentage change as final value minus initial value upon initial value into 100. Let's take a very simple example. Revenue in 91 is 36. Revenue in 94 is, let's say, 45. So what is the percentage change here? 45 minus 36 upon initial value 36, which is equal to 9 upon 36, which is equal to 1 by 4, which is equal to 25%. What is another way of calculating percentage change? Just take the ratio. Let's say we have to calculate percentage change from 91 to 95. Just take the ratio 60 upon 36. This is 10 times 6 times 5.3. 5.3 is 1.67. Subtract 1 and take percentage. So this becomes 67%. I hope this is clear to you. CAGR and SAGR. CAGR is also called compounded annual growth rate and SAGR is called simple annual growth rate. What is the difference? Let's understand. For example, this company grows from 36 to 45 in how many years? 91 to 92 1 year, 92 to 93 2 years, 93 to 94 3 years. What is the growth from 91 to 94? The growth is 45 minus 36 upon 36, which same as percentage change. So this is 25%. What is SAGR? So from 91 to 94, there is a growth of 25% and there are 3 years. So therefore, simple annual growth rate is nothing but 25 upon 3, which is 8.33%. In case of CAGR, it is given as final value upon initial value raised to the power 1 by n minus 1 into percentage into 100%. So in this case, let's say this is 45 and this is 36 raised to the power 1 by n minus 1 into 100%. 45 upon 36, this is 5, this is 4, this is 1.25 and here n is equal to 3. So we have to do 1.25 raised to the power 1 by 3, a cube root of 1.25. Very simply, 1.08 into 1.08 will be approximately 1.16 into 1.08 will be approximately 1.25, but it will be slightly more than 1.25. Why? You can do it yourself. What is 108 square? 108 square is 11664. So 1.08 square will be 1.1664, which is approximately 1.17. Into 1.08 you will do, it will certainly be more than 1.25. So since you have to get equal to 1.25, you will have to get less than 1.08. So approximately 1.078 or 1.079 you can take. So approximately the answer will be 7.8%. So CAGR is 7.8% and SAGR in the same case is 8.33%. Multiplication factor is converting a percentage increase or decrease into a multiple. For example, let's say I have to increase a number 20 by 20%. If I have to increase a number by x percent, I have to multiply the number by 1 plus x upon 100. And if I have to reduce a number by x percent, I have to multiply the number by 1 minus x upon 100. So in this case, 20% increase means multiplication by 1.2, finally giving me 24. If I have to reduce the number by 20%, I have to multiply the number by 0.8, finally giving me 16. Now this looks quite simple and trivial, but very powerful when you have to do percentage increase, percentage decrease. In a lot of questions you will see this. Converting a percentage change into a multiplier speeds up the calculation. Try it and you will realize the difference. Let's move forward talking about fractions. One thing that you must do from data interpretation standpoint is fraction table. So what is a fraction table? You have fraction here, as you can see, from 1 by 2 to 1 by 19, and the first multiple of this fraction is 1 by 2 is 50%, 1 by 3 is 33%, going on till 1 by 19, which is approximately 5% or slightly more than 5%, 5.3% approximately. Now if you know these fractions, okay, once you start practicing them, you will remember them. So what you should do is you can take a screenshot of this, take a printout and put it where your study table is, so that you can revise it. Once you know the first multiple, you can calculate all the other multiples very easily. For example, let's say 1 by 8 is, let's say, 12.5%. So then 3 by 8 is very simply 3 into 12.5%, which is 37.5%. So do learn the fraction table if you really want to be solving DI questions faster. Another important aspect which is there in DI is ratio comparison. Let's understand one key property. Whenever I have a fraction which is less than 1, if I add something to the numerator and denominator, then the fraction must increase. An example is 3 by 4 is less than 1. If I add something to numerator and denominator, let's say add 1 and 1. So this becomes 4 by 5. Earlier 3 by 4 is 0.75. Now 4 by 5 it is 0.8. So you can see the value has increased. So whenever you have a fraction less than 1, you add something to the numerator and denominator, same number, then the fraction increases. If you have a fraction which is greater than 1, let's say a by b greater than 1, add something to the numerator and denominator and the value will reduce. Example, let's say 3 by 2, which is 1.5. I add, let's say, 1 to the numerator and 1 to the denominator, becomes 4 by 3, which is 1.33. So you see the value has reduced. So you can apply it in some of the ratio comparison questions that are part of data interpretation. Moving forward, getting squared with squares. Now you see a lot of squares that are there as part of DI, and not just in the same shape and form. For example, you may not get a 13 square. You can get, let's say, something which has to be increased by 30% for 2 years consecutively, right? So if it has to be increased by 30%, the multiplier is 1.3, and then when you square it becomes 1.69, which is nothing but 13 square divided by 100. Remembering these squares will help you in multiple ways in data interpretation. So one way to begin this is you should remember squares which are very active. So numbers still, let's say 25 or 30 are quite active. So you can remember these numbers, and post which you can calculate some of the numbers. A way to calculate any number in 5 is very simple. For example, 35, if you have to calculate 35 square, so all you have to do is write 25 here. In the first two places, multiply this number with the next number. So what's the next number? 4. So 3 into 4 is 12. What is 45 square? Write 25 in the first two places, 4 into the next number, which is 5. So 4 into 5 is 20. This is quite simple. If you have to, let's say, square any number between 25 to 50, if you have to square any number, let's say take 43, what you have to do? So take difference with 50. What is the difference? 7. Now subtract this number with 25. What do you get? 18. And just square this number and place it here in two places. So 7 square will be 49. So 43 square is 1849. If you have to square any number between, let's say, 50 to 75, the process is quite similar. Here, if you have to take, let's say, any number 63 square, if you have to calculate. Now all you have to do is take difference with 50, you get 13. Now add this 13 to 25, you get 38. 13 square is 169. So all you now need to do is add this 169 here. If you add it here in 3 places, it will be a blunder. Why? Because 63 square cannot be 5-digit number. You have 30 square, which is 900, 31 square, which is 961. 32 square is the first number where you get 4 digits. So 32 square is 1024, 33 is 1089, 34 is 1156, 35 is 1225, 36 is 1296, going on down till 99, which is 9801. All these numbers are squares having 4 digits. So this can't be a 5-digit number. So you have to place 1 here. So this becomes 3969. I hope this is clear to you. So if you have to calculate any number between, let's say, 75 and 100, in that case also, let's take any number, let's take 88. So what you have to do, take the difference first with 100, you get 12. Now take the difference with the original number. So 88 minus 12 is 76. Now 12 square is 144. You know that you can't place here in 3 digits because this will also be a 4-digit number. So you place it here. You get it 7744. 7744 is the only number of the form XXYY, which is a perfect square. This has been a CAT question also. I hope this is clear. clear to you. And finally, let's say you have a number which is more than 100. So then how to go about it? Let's say you have a number between, let's say 100 to 125. Let's take some number. Let's take 108. So what do? Now this number will be a 5 digits square, right? So 108 square. Take a difference with 100, you get 8. Add 8 to the original number. 108 add 8 becomes 116. And 8 square is 64. So append here. So 11664 is the square of 108. Another interesting factor, any number, x square, 50 minus x square, 50 plus x square, 100 minus x square, 100 plus x whole square, all these numbers end in the same last 2 digits. Let me ask you a very simple question. What is 2142 square upon 100 and remainder? See, this is some number plus 42 or 2150 minus 8 whole square. So it must end in the same last 2 digits as 8 square. So the answer here must be 64. I hope this is clear to you. Again, quite an interesting thing, isn't it? Think about it, take a few examples and solve. Moving forward, let's swallow the cubes. We have to swallow the cubes at least till 12, but it's even better if you can remember till 20. And it comes in handy in a lot of questions, in a lot of approximations that you do, where if, for example, let's say you have to do 1.3 into 1.3 into 1.3, right? So if you know that this number is going to be 2.197, you can write it directly. If let's say you have, for example, you have 1000 rupees invested into compound interest, right, for let's say 30%, increased for 3 years, invested for 3 years. In that case, what will be the amount? The amount will be 1000 into 1.3 raised to the power 3. So this is 2.197, just multiply. Let's move forward. Now let's talk about the art of approximation. How well can you approximate depends on a few things. Okay, one, if there is a room for approximation. A lot of questions you see where the answer options are quite well separated. That's an invitation for approximation. If the answers are very, very close, don't do it. Second thing, approximation also depends on how well are you doing on the hygiene aspects. For example, cubes, squares, fractions, percentages. If you are really well versed with the hygiene aspects, you can approximate better than others. And third thing, finally, is practice. The more you practice approximation, the better you get at it. You start developing sense of approximation. How do we calculate something like 2.15 into 0.168? Let's see. So what is the approximation that we can do? The first thing about approximation is either break down things or convert things into something that you know, some forms that you know. For example, I can convert this 2.15, increase it slightly, make it 2.16. Since there is a multiplication, if I increase one slightly, I reduce one slightly, should not make much of a difference. So I increase it slightly, becomes 2.16. I reduce it slightly, becomes 0.167. And you will realize, why am I doing this? Think about it. You must have seen 216, right? Let me show you. Do you see 216 here? So you can write this number as 6 cube upon 100. Have you seen this number? This number is also right up there. If you see 1 by 6 approximated to 17% is nothing but 16.7%, and in decimal 0.167. So now this number can be written as 1 by 6. How simple is this calculation? Is nothing but 6 square upon 100, 0.36. Could be done mentally, right? That's the first thing. Let's take another example to understand approximation. Approximation is also about knowing a few shortcuts or tricks. Let me teach you one very interesting shortcut. 280 upon 3.96. I can write this as 4 into 0.99. I can then write this as 70 upon 0.99. Then I can write it as 70 upon 1 minus 0.01. Here is the shortcut. You have n upon 1 plus x. You can write this as n into 1 plus x to the power minus 1. Whenever x is very, very small as compared to 1, then this minus 1 gets multiplied here. So this becomes n into 1 minus x. In this example, 70 upon 1 minus 0.01 can be written as 70 into 1 minus 0.01 raised to the power minus 1. Since 0.01 is very small as compared to 1, I can multiply this minus 1 here, and this becomes 70 into 1 plus 0.01. So this becomes 70 into 1.01. 70 into 1.01 will be 70, plus if you multiply it here, this 7 goes and this becomes 0.7. So 70.7 is your final answer. I hope this is also clear to you. Another example, 3.3 upon 37. It's also about, approximation is also about, using what you know and, being able to see patterns. So for example, let's see 3.3, right? 3.3 can be approximated as 10 upon 3. So for example, 10 upon 3 and this is 37. So this becomes 10 upon 111. You have to convert it into percentages. So multiply with 100. So this becomes 1000 upon 111, which is approximately 9%. So I hope this is clear to you. So as you practice more, you get better at, the art/science of approximation. Let's move forward, getting down to the roots. The roots are very, very easy to remember. Let's see. For example, root of 2 is 1.41, all of us know. Root of 3 is 1.73, many of us know. Root of 1, root of 4, root of 9, root of 16, these numbers are already known to us. If you remember root 5, then you can build on and calculate all the roots till 15. All you have to do is remember root 5 is 2.24. Once you know root 5, all you have to do till 8 is keep adding 0.2. So you add 0.2 here to 0.244, add 0.2 to 0.64, add 0.2 to 0.84. So these are keep adding 0.2 club, right? Now 9 is 3, you already know it. After that you have again, 3 numbers wherein this is called keep adding 0.16 club. Keep adding 0.16, again 0.16, 0.16. So 12 square root is 3.48. And after that you have keep adding 0.13 club. So you add 0.13, 3.61, 0.13, 3.74, 0.13. Talking about cube roots, I never remembered cube roots, but I can calculate cube roots approximately. So let's try and calculate cube root of 3.48. So I have to calculate 3.48. The first thing that comes to my mind is, what is the cube that I know is closest to this number? I know 1 cube is 1. I know 8 cube is 2. Cube root of 1 is 1 and cube root of 8 is 2. So cube root of a number between 1 and 8 must lie between 1 and 2. If you know the cubes, 15 is 3375. So that's the advantage of knowing the cubes. 1.5 cube is 3.375. 1.6 cube is 4.096. So the answer will be between 1.5 and 1.6. So what you can do is you can approximate it somewhere between 1.5 and 1.6. And finally, moving forward to, let's say, a power. Some powers that we have to remember, power of 2 at least till 10 and power of 3 at least till 5. So every day 5 minutes is quite enough to improve on this aspect and gain on the speed for data interpretation. Thank you so much for joining in. God bless you all. Take care and bye-bye.